Hello viewers, welcome to another lesson of the Upper Basic, a continuation of the third lesson. This is the fourth lesson, lesson 4. And today we'll be treating inverse operations. What is an equation? An equation is a mathematical statement in symbols that two things are exactly the same or equivalent. Equations are written with an equal sign, as in 2 plus 3 equals 5. This qualifies an equation because it consists of numbers and an operation. And the existence of the equal signs here also qualifies this as an equation. The second example here, we have 9 minus 2 equals 7, almost the same as the first one. We see numbers, we see an operation, and an equal sign. So these two are qualified to be called an equation. An equation can be compared to a balanced scale. Both sides need to contain the same quantity in order for it to be balanced. We have a beam balance here. We can see it has two sides, and there's a pivot in between these two sides. Whatever quantity you put here must also equate to what you put on the right-hand side. You have two sides, the left-hand side and the right-hand side, if you want to have a balanced scale. If the quantity you put on the right-hand side is more than what you put on the left-hand side, you wouldn't have a balanced scale. Let's have a look at this. There's a simulation here that will help you understand this very well. This is a seesaw. As you can see, on the right-hand side, on the left-hand side, we have 20 kilograms here, and we have 20 kilograms also on the left-hand side. Okay? And by looking at it, we understand that this is balanced because they are at par. Okay? Both sides are equal, which is why it's balanced. So to prove this, let us add 5 kilograms to the left-hand side. As we can see, the left-hand side is heavier than the right-hand side, so therefore it outweighed the right-hand side. Okay? If you further want to prove this, we add 5 onto the right-hand side as well. As we can see, we have a balanced equation here as well. Okay? When you are playing these games in your schools, if child A is heavier than child B, we can see the child A will outbalance child B. So this is the same thing that we'll be using in our equations. For example, 20 plus 30 equals 50 represents an equation because both sides simplify to 50. 20 plus 30 is equal to 50. And yes, so therefore we have a balanced equation here. Okay. Any of the numerical values in the equation can be represented by a variable. As we said in our previous lessons, variables can be numbers, and they can be letters and can be symbols as well. Example here, 20 plus C equals 50. We replace 30 here by a variable C. Okay? And then we further went on X plus 30 equals 50. What did you see? We have replaced 20 here with another variable X. And then we can further see 20 plus 30 equals 50. We have replaced 50 with a variable Y. Now, here's an instruction. When solving equations, the goal is to isolate the variable. on one side of the equation. The variable must be alone on one side of the equation to isolate the variable in order to determine its value. For us to know the value of the variable, we must make sure the variable is on one side of the equation. Now, in order to solve an equation containing a variable, there are things that we need to do. We need to use the inverse, that is the opposite, or the undoing operations on both sides of the equation. Let's review the inverse of each of the following operations. We have addition here. The inverse of addition is subtraction, or the opposite of addition is subtraction. And multiplication, the inverse of multiplication is division. We will come to do some problems that will involve all this as we go. To solve for x in the following equation, we have an equation here that says x plus 7 equals to 32. Now, to know what operation we will be using to find the value of x, we have to do a reverse of positive 7 here. We have x plus 7 equals to 32. As we said in our previous slide, we need to isolate the variable for us to find the value of the variable. So in isolating the variable, we must make sure the variable is alone here. How do we do that? By undoing the 7. How do we undo the 7? By using the inverse operation of the 7 here. You can see a 7 is a positive 7 plus 7. So the inverse of plus is subtraction. So all we need to do is we subtract 7 for us to undo the 7 here. But let's take note that whatever we do, an equation has both two sides. Whatever we do on one side, we must do on the other side. So subtracting a 7 here, we must also subtract a 7 from the other side, beyond the equal sign. So which is why we'll have something like this. X plus 7 equals to 32. And we must subtract 7 from here in order to isolate the variable. And if you subtract 7 here, we must subtract 7 on the other side as well. And therefore, 7 will cancel out 7. 7 minus 7. We are left with only x here. And 32 minus 7 is 25. If we want to prove our answer, all we need to do is substitute the value of x as 25. We know our x now, 25. So therefore, 25 plus 7 on one side of the equation and 32 on the other side of the equation. 25 plus 7 is 32 equals to 32. This tells us that we have a correct equation because both sides must be equal. Now, for each equation, write the inverse operation needed to solve the variable. As we have here, y plus 7 equals to 14. Now, what we need to know here is the operation here is an addition. So in order to isolate the y here, which is our variable, all we need to know is the opposite of addition here is what? Subtraction. So for us to isolate our variable here, we must subtract 7 from here. And remember, whatever we do here, we must do it to the other end, but we are not interested in finding the value. All we need to know is what shall we do here to isolate our variable y. And in doing so, we would be subtracting 7. Let us confirm. Subtract 7, as we said. B is A minus 21 equals to 10. Our equation here is A minus 21 equals to 10. In order for us to isolate our variable A here, all we need to do is look out for the operation here, which is subtraction. And the inverse of subtraction, therefore, is addition. So in doing so, we will be adding 21 to isolate our variable A. Add 21. C, 5s equals to 25. Our equation here is 5s equals to 25. For us to isolate our variable s here, we need to know the operation that we have here. 5s means 5 times s. So because we are multiplying here, the inverse of multiplication is division. So therefore, we will divide this by 5 so we can isolate our variable. Divide by 5. Let's move on to the final one, D. We have x over 12 equals to 5. That is our equation here. But what operation is taking place here? We can see it is a division, x divided by 12. So having a division, the inverse of division is multiplication. So therefore, in order to isolate our variable here, we must multiply by 12. Multiply by 12. Now let's think about this. To solve C minus 3 equals to 12, which method is better and why? Of course, we have two methods here. Let us compare these methods and know which method is better and why do you think one method is better than the other. Now, the first method that we have here, we have two equations now, and we assume that this is Lamin working in this way and Ibu working in the other way. So this is how Lamin did. C minus 3 equals to 12 as an equation. What Lamin did was to isolate the C, he undo the 3, like add 3 to minus 3. This definitely undo the 3, and then we have C equals to 12 plus 3, which is 15. This is what Lamin did. And let us see Ibu's work now. They got the same equation, C minus 3 equals 12. Subtract 12 from each side, then add 15. Ibu subtracted 3 from each side first, 3 from each side. So we have negative 3 minus 12. We have C minus 15. This is 15. This equates to negative 15. So C minus 15 equals to 0 because 12 minus 12 is 0. Then again, he added 15 to isolate his variable, C. In isolating his variable, the operation here is an addition, it's a subtraction, sorry. And the inverse of subtraction is addition. Then he added 15 to both sides. This 15 undoes the 15. And then we end up having 0 plus 15, C equals to 15. Now the question is, both Lamin and Ibu have the same answer. As we can see, Lamin's work is only a one-step solution, and Ibu's work is a two-step solution. He added 12, he subtracted 12 onto both sides, from both sides, and then added 15 onto both sides to undo the negative 15 and isolate the variable. So the reason that, by the look of things, we know that Lamin's work is easier, it's a one-step solution. And we can see Ibu have 2 steps to get to the solution. Why? Because Lamin undo the smaller number first to isolate his variable, but Ibu undo the bigger number to isolate bigger number first, and then later on isolate his variable C. So we can see that Lamin's work is simpler than Ibu's work because a one-step solution, and Ibu's work is a 2-step solution. Think about this. In the expression negative x over 5, to which does the negative sign belong? We have the x as the numerator and 5 as the denominator. We can see the equal sign is in between them, but where does it actually belong? Does it belong to the x, the 5, or both? Let's find out. The answer is that there is one negative, so it is used once with either the variable or the 5, meaning the negative sign can only be that of the x or the 5, but it cannot belong to both of them simultaneously at the same time. Generally, we assign it to the 5 to avoid creating a negative variable. The variable is an unknown here. To avoid creating a negative variable, we assign the negative to the known number, the 5. So this is shown here, negative x over 5. It can belong to the x and the 5, but generally, we give it to the 5 to avoid a negative variable. We do not make our work a little bit difficult. We have response question here, and I want us to be doing this together. Why I'm solving this here, and I would also want you to be doing this with me whilst you are sitting there. What is the inverse operation needed to solve this equation? The equation at hand here is 7x equals to 49. We need to know the operation involved first, then we can know the inverse operation that we will use to isolate our x. 7x equals to 49 is definitely equals to 7 times x equals to 49. The operation we have here is a multiplication. And we've discussed this before that the inverse of multiplication is division. So therefore, our correct option here is D, that is division. What is the inverse operation needed to solve this equation? There's another equation here. X minus 3 equals to negative 12. X minus 3 equals negative 12. First, we have to know the operations involved. Then we use their inverse to isolate our variable. We can see we have x minus 3. So a negative sign is involved here, and the inverse of negative is addition. So our addition is the correct answer here. Option. One-step equation. Now we will get into solving our equations. But the equations we'll be solving here are only one-step equations. Now, here are hints or rules to adhere to or to bear in mind in solving one-step equations. To solve equations, you must work backwards through the order of operation to find the value of the variables. We talked about our order of operations here the last time. Now, to solve equations, you have to use backwards, that's the reverse of both maths, starting with either the addition or the subtraction, coming into the multiplication or the division, and the brackets comes later on. The second hint here, he says, remember to use inverse operations in order to isolate the variable on one side of the equation. Let us always use the inverse operation in order to isolate our variables. Like we previously did, let us identify the operation there and use the inverse of that operation to isolate our variable there that is given. Whatever you do, the third hint says, whatever you do to one side of an equation, you must do to the other side. Must, in uppercase letters, in capital here, is telling you it is obligatory to do whatever you do on one side of an equation, you must do it to the other side. Now we have an example here. Y plus 9 equals 16. Y plus 9 equals to 16. This is what we have here. Now, the inverse of adding 9 is subtracting 9. In the equation, we have y plus 9. So we want to isolate our variable here. How do we do it? By taking the inverse of plus 9, which is what? Minus 9. So in subtracting 9 from both sides, remember we must do justice to both sides. Whatever we do on one side, we must do it onto the other side. So this undoes the 9. We have y equals to 16 minus 9, which is 7. There's a second example here. We say 6m equals to 72. 6m means 6 times m. Therefore, the operation here being a multiplication. And the inverse of a multiplication is division. So therefore, we must divide both sides by 6. And that will undo the 6. So we have m equals to 72 divided by 6, which is 12. Still on one-step equations. Can we solve this together as well? X plus 2 equals to negative 14. As you can see, the root of the equation here is, the answer here is negative 14. X plus 2 equals to negative 14. So the operation here is a positive, and the inverse of positive is negative. So therefore, we subtract 2 from both sides. In doing so, this undoes this, and we have x is equal to negative 14 minus 2 is negative 16. We have 7 equals to x plus 3. 7 equals x plus 3. And our operation here is an addition. So therefore, first we think of the inverse of addition, which is subtraction. This will compel us to subtract 3 from both sides. And by doing that, this will undo this. And then we have 7 minus 3 is 4 equals to x. The value of x, our variable here, is 4. Okay, let's solve this as well. X plus 5 equals 3. Our operation here is an addition, and the inverse of addition, as we say, is subtraction. So we must subtract 5 from both sides. Then we shall have x, x is equal to, as this undoes this, 3 minus 5 is negative 2. We have 15 equals to x plus 17. 15 equals x plus 17. Our operation here is addition, as we can see. And the inverse of addition is subtraction. So in order to isolate our variable, we must subtract 17 from both sides. And in doing so, this undoes this, and then we have 15 minus 17, we have negative 2 equals to x. We have 3x equals 15. 3x equals 15. As we said before, 3x means 3 times x. So the operation here is a multiplication, and the inverse of multiplication is division. So all we need to do is divide here by 3 and divide this side also by 3. So 3 cancels 3, 3 will undo 3 here. And then therefore our x will be equal to 3 goes into 15, 5. We have x over 2 equals to 10. First, our operation here is a division because we are dividing x by 2, which equals to 10. So the inverse of division is multiplication. So let's multiply both sides by 2. Multiply here by 2, and multiply here also by 2. Okay. So 2, this 2 will undo this 2. So we have x equals to 10 times 2, which is 20. Now we have a question here that has already been solved. So let us go over it. Negative 4x equals to negative 12. The operation here is a multiplication because negative 4 times x represents a multiplication. So the inverse of multiplication is division, which is why we divide both sides by negative 4. Negative 4 undoes negative 4 here. And you have x equals to negative 12 divided by negative 4, we have 3. Okay. Same thing, a very similar one with this one. And then we have another one here, x over negative 6 equals to 36. We are dividing here, as you can see, because we are dividing x by negative 6. So we multiplied both sides by negative 6. As you can see, negative 6 on both sides. This negative 6 undo this. So we have x is equal to 36 times negative 6, which is negative 216. One-step equation still. Negative 4x equals to negative 12. To identify operation, as we said, negative 4, this means negative 4 times x. So therefore, our operation here is multiplication. And the inverse of multiplication is division. Therefore, we'll say negative 4x is equal to negative 12. We therefore divide both sides by negative 4. And then as you can see, negative 4 undoes negative 4. So x therefore equals to 12 divided by negative 4. We have 3 as answer. We have negative 25 divided by negative 25 equals to 5x. Still, the operation here is a multiplication, meaning 5 times x. And the inverse of a multiplication is division. So in order to isolate our x variable, our variable x here, we need to divide both sides by 5. 5 undoes 5. Negative 25 divided by 5 is negative 5. So negative 5 equals to x as our answer. The third one here is x divided by negative 6 equals to 36. As you can see, the operation here is division, and the inverse of division is multiplication. So therefore, we shall multiply both sides by negative 6. And negative 6 undoes negative 6. We shall end up with x equals to 36 times negative 6. 6 times 6, that is 36. 6 divided by 3, 6 times 3, 18 plus 3, 21. So we have negative 216. So we have response questions here. We shall go over 2, and then I'll give you some assignments that you will do at home, and we shall go over in our subsequent lessons. Solve x minus 6 equals to negative 11. We are asked to solve this. Let's solve this together. We know the operation given here is a subtraction, and the inverse of subtraction is addition. So in order to do this, x minus 6 equals to negative 11. In order to isolate our variable x here, we have to add 6 onto both sides. This should undo this. And then we have x equals to negative 11 plus 6, which is negative 5. We have j plus 15 equals negative 17. J plus 15 equals to negative 17. The addition here is, the operation here is an addition, and the inverse of addition therefore is negative, so we subtract 15 from both sides. This shall undo this, and then we'll have j equals to negative 17 minus 15 is negative 32. Solve negative 115 equals to negative 5x. Negative 115 equals negative 5x. As we said before, this means negative 5 times x. So the operation here is multiplication. So therefore, the inverse of multiplication is division. That way we will divide both sides by negative 5 in order to isolate our variable. So let's divide here by negative 5 and divide here by negative 5. Negative 5 cancels out. Say 5 goes into 11 2 times. Remember one, it goes into 15 3 times. Because we are dividing a negative number by a negative number, answer changes to positive. So we have 23 equals to x. Which is the same as x equals to 23. Solve x over 9 equals to 12. The operation at hand here is a division. X over 9 equals to 12. As I said, the operation we have here is a division. So therefore, the inverse of division is multiplication. So all we need to do is multiply both sides by 9, that will help us to isolate our variable, which is x. And therefore, this will be 9 times x over 9 equals to 12 times 9 as well. So this cancels out. We have x equals to 12 times 9 is 108. Solve 51 equals to 17y. 51 equals 17y. As we said before, 17y means 17 times y. So the operation there is, this is the same as 51 equals to 17 times y. So the operation we have here is multiplication, and the inverse of that is division. So 51 equals to 17y. All we need to do is divide both sides by 17. 17 cancels out, 17 undo 17. It's a 17 into 51 3 times. So therefore, y equals to 3, or 3 equals y. Negative 3 equals to x over 7. Negative 3 equals to x over 7. The operation here, x over 7, means x divided by 7, so it's a division. And the inverse of division is multiplication. So we would be multiplying here to isolate our variable. In doing so, we multiply here by 7, and we multiply this side as well by 7. 7 undo 7 here. 7 times negative 3 is negative 21 equals x. Negative 21 equals to x. Solve 23 plus t equals 11. 23 plus t equals 11. We have 23 plus 3. Our variable here is t, and then the operation that happens here is an addition. So there, and this 23 being a positive number, the inverse of addition is subtraction. So we are subtracting 23 from both sides. And this will undo it. So we have t equals to 11 minus 23. Our answer is negative 12. Solve 108 equals to 12r. 108 equals 12r. We did something that is very similar to this. 12r means 12 times r. So the operation here at hand is a multiplication, and the opposite of multiplication is the reverse, or the inverse of multiplication is division. So here we are dividing by 12 in order to isolate our variable r. We divide here by 12, and we divide here by 12. 12 cancels, and then 12 into 108 is 9. So therefore, 9 equals to r, which is the same as r equals 9. So this ends our today's lesson. We will definitely do two-step equations in our next lesson. I thank you so much for being there. And again, keep washing your hands as much as you can. Adhere to the precautionary measures. Avoid crowds. This shall also come to an end. And I know we shall overcome. Thank you.